Welcome to my lesson. This lesson is part 2 of my lessons on normal probability distributions. Again, the lessons here are not intended to cover all the sections of statistics in their entirety. Rather, they are intended to focus on areas which, in my experience, students have demonstrated a lack of understanding or areas of confusion. So the lessons that I provide here are designed to do a couple things. First, they allow a little comparison and contrast to help clarify and dispel that confusion. And the second one is to also provide students with an illustration of the kind of work that I would expect of them when they're given homework or quizzes or tests that I like to be able to see, so that students are able to demonstrate to me that they have a clear understanding of the problem and can clearly demonstrate the work to getting the solution. So you'll notice that for the purpose of these lessons, that students, at least my students, for these videos, do use a TI-83 or 84 graphing calculator, and that a lot of the calculation work is done with that tool. Having said that, though, my hope is the other aspects of this lesson will hopefully provide some clarification as to the similarity and differences of approaching these questions, which have a lot of similarities but subtle differences, so that they require different types of mathematical work. So what we're looking at here are general applications of the normal distribution, but we're going to compare two different problems, one with a regular normal distribution and one requiring application of the central limit theorem. If you watch my first video on this, it would make a whole lot more sense to see the kind of work that I'm going to be doing with this problem going forward, because I show the 3 steps that I require for solving any problems like this, like the problem you see on the left. And in understanding that, it's going to make a whole lot more sense to understand how applying the central limit theorem changes each of those 3 steps. So those 3 steps that are involved here are going to be providing a probability statement, drawing a normal distribution, and then the calculator work necessary to successfully complete the problem. So let's go ahead and take a look at what problem is being asked here. So, and I'll move down as we need to here. So the problem information for both of these questions is Prior Airlines currently has a seat width of 18 inches. Men have a hip width that are normally distributed with a mean of 15.4 inches and a standard deviation of 1.1 inch. So the first problem says, find the probability that if an individual man is randomly selected, his hip breadth will be greater than 18 inches. So we're going to go ahead and we're going to work with this. So one thing that tells us that this is just kind of a generic problem is we're looking for an individual man, and it's his hip breadth. So this is what's telling us, because we're looking for one thing. This is going to be a random variable x, and because of that, we're going to first write out the probability statement for this. So we want to know the probability that their hip breadth will be greater than 18 inches. So for the probability statement, we're going to have that the x value is going to be greater than 18. So that's the probability statement we're looking for, and we're going to hopefully answer the question to that, and we'll put our answer there. Let's go ahead and take a look at the other problem we have, where we are required to apply the central limit theorem. So here the question asks, find the probability that if 16 men are randomly selected, their mean hip breadth will be greater than 17 inches. Now notice here, this number here is a little different, and in this case we're looking for 16 men, not 1, but 16. And we want to know the probability that the mean hip breadth, so the mean. So if you're looking for more than one person, like more than one random x value, and you're looking for the mean, this is going to be a tip-off that tells you this is going to be an application of the central limit theorem. So how does the work from this problem differ from what you see here? So in this probability statement, we're not looking for a random x variable, we're looking for a mean. The probability that a mean will be greater or less than something. So this is going to be x bar is going to be greater than 17. So what's one key difference? One key difference is how we write the probability statement. Here, for one individual, it's just going to be x, like we've seen in previous problems. Here, the difference is going to be in x bar, and that should be included in the probability statement. So you are demonstrating to me that you know you're applying the probability that for a mean of values, that's what you're finding the probability of. So that is one key difference. Let's go ahead now and draw the normal distribution in each situation. So we start drawing a normal distribution, and here we're going to draw an x. In the second situation, we draw that horizontal line, but here we're drawing an x bar. So that's going to be one difference we have. So here is going to be x, here is going to be x bar. Now, let's take a look at how we draw the normal distribution for this and how I draw the distribution for this. So, okay, that's not a bad normal distribution. But since we're comparing the same information in this here, one thing that you should be aware of is that if you are looking at a random variable, there's going to be, we expect there to be a fair amount of variability. But if we're looking at the means, there should be less variability among the means, and that's something that's been taught in the lesson. So we would not expect, given that we have the same information above here, that we don't expect the bell-shaped curve to be the same. This bell shape would actually be taller and thinner because there's less variation. That's why the standard deviation for means is smaller. So we would expect a taller, thinner curve here. So the shape is going to be different from this one to this one. Okay, so that's one more. That's another difference. Here we have the mean. So the mean of this is going to be 15.4. Okay, but here for this one, it's not just the mean. It's going to be the mean of the sample means. So it's going to be the mean of the sample means. Now this is also going to equal 15.4. Because one thing that you should have learned in the book, or that you'll find in the book, is that mu is going to be equal to, mu. So the mu of random x variables is going to be equal to the mu of the sample means. So if you have difficulty understanding that, because I know that central limit is a challenging topic for students, okay, there are videos on YouTube that are here to assist with that, and I'm not going to teach that subtle difference today, because that's a whole different topic, and you can find a lot of videos on YouTube that can assist you with that. But in terms of showing the work, this would be a detail I would expect when you are answering an application problem requiring the application of the central limit theorem. So I would expect to see this here. I think beyond that, I think we are okay. So here we want to know the probability that's greater than 18. So we're going to put this here, put 18 here. Here we want to know the probability that x bar is greater than 17, so we're going to go ahead and put 17 here. So we have the proper shading there. Okay. So what are our differences? First difference is how we label the horizontal axis. The second difference is how we illustrate the center or the mean of the graph, how we show that work there specifically. And then the third difference is in the shape of the bell curves. Okay, so is in shape. Well, that's the second difference here. So if you watch my first video on this, you'll already be familiar with the steps that are on the left-hand side. My purpose here is when you need to apply the central limit theorem, how do the steps on the right differ? And it's not big, but they're still different. All right, so let me go ahead to the third part now, is how do we put this into the calculator? So when we put this into the calculator, this is going to still be the normal CDF. This will also be the normal CDF. This one is going to be, and I'll write the information on here. The left bound for this is going to be 18. The right bound for this will be 99999. And again, you may use whatever right bound you want as long as it works. The mean for this will be 15.4. And then the standard deviation for this will be 1.1. For this one here, so now this is only, okay, so this difference here of the right bound, of the left bound being 17, this is only different because the question is different. They don't necessarily have to be different. They may be the same. So this difference between the left bound between these two questions is only because the questions are different. It's not a difference based on the process. Okay, this would be 9, 9, 9, 9, 9, 9. Again, the mean is 15.4. The difference in the process now enters in, because when we are calculating, and I'll put this up a little more now, when we are calculating the probability of this, because it is a sample mean we are looking at, we need to take the standard deviation and we need to divide this by the square root of the sample size, which in this case the sample size is 16, because that's what they mentioned in this problem. So it's going to be 1.1 divided by, and we can just put the square root right in. And I believe there's going to be a parenthesis for that. And then you can go ahead and close that up. And let's see, and we can type both of those in and come up with a calculation for that. So I'm going to show all of this work that I have here. And we'll go ahead and calculate each of these. So the first one I get calculated is going to be right here. Second distribution, number 2. So this will be 18. 15.4, 1.1. And notice here that this is like 0.00904, so this would be 0.0090. Okay, so pretty small percent. Okay, let's take a look at this one. Now, this one may actually like yield this actually you would think might be greater because that's 17 out of 18, but actually I suspect it's a bit smaller. So let's take a look at this. So it'd be 17, 99999. We have to type that in. 15.4. This is going to be 1.1, and this is going to be divided by the square root of 16. Yeah, this is like 2.98 times e to the negative 9. Now, so 2.984, so I'm going to say this is going to be 2.984. Now, e to the negative 9 is the same as times 10 to the negative 9. Now, since the negative 9 means I'm going to have like 8 zeros. I would be fine with this answer. 2.984 would be like the official answer, but notice here that's a really highly unlikelihood. For maybe like a person, it's like just a little under 1%, but this is like, it would be very rare. It's like almost out of a billion chances. So and that's why in these kind of questions, you know, finding one person is less than 1%, but having the mean be greater than that of 16 people, really, really unlikely. You have to have some, you know, maybe if they were like basketball players, for example, they're all exceedingly tall, that could be the case, but it's not a likely occurrence. So you want to make sure the key difference in how we did the calculations in this one is that we have to make sure we take our standard deviation and divide it by the square root of the sample size. So again, the main purpose of this lesson today is to not really teach so much about the central limit theorem, but just is how does our work with a regular normal distribution problem, how is it similar and different to how we use it for a central limit theorem? So you're not learning how to do a central limit problem all over again, you're just learning about the key differences so that when you're showing your work, you know how to tweak the work so that you can clearly demonstrate and correctly calculate how we find an application problem requiring a normal distribution where the central limit theorem needs to be applied. Thank you very much.